Hey everybody, welcome back to Jim's Garage. This video we're going to be concentrating on deploying Ceph within Proxmox. Apologies up front if my voice is a bit croaky. I've probably had COVID for a few days, but I'm soldiering on for you folks out there. So I'll be deploying Ceph on my MS-01 cluster, but you can use any devices you have. Recommend a minimum of 3 so that you can have 3 copies of your data, so any one node fails, you've still got 2 copies. Now, there are some requirements that are recommended. There are the hard requirements from Ceph itself, but there's kind of the unofficial, more home lab friendly recommendations that I will touch on. Do recommend you go and check out the official documentation, and that goes throughout this whole video. I will skim the surface on some of the key elements, but there's a lot to Ceph. It's pretty complicated, so it is really beneficial to go and check those documents. Now, people have reported running this on 1 gig networks and it working. I would recommend probably a minimum of 10 gigabit, and also to not use spinning disks, but to use a minimum of SSDs or preferably NVMe drives. That's going to give you the quickest replication between nodes. And I know previously from using things like Longhorn, which is kind of a similar concept, definitely not the same execution. That was having difficulties when I was running it on 1 gig, especially when I was trying to do large replication jobs, multiple gigabytes. What was happening is the data couldn't copy quick enough before the data had already started changing, and you'd run into all these weird syncing issues. So I recommend a minimum of 10 gigs. So hopefully that's a warning if you can't get this working or you're experiencing bad behavior. So why use Ceph? Well, that's because it consolidates the storage across your nodes. Now, you don't have to use this just with Proxmox. You can use it pretty much with any Linux distribution. It's just an obvious choice for something like a hypervisor. It has lots of benefits because you can effectively abstract your storage away from your nodes, and you can easily add more storage and have replication of your data such that if a node fails, you should have copies of that data elsewhere. It's also great for high availability because each node is going to have a replica of that VM or containers data, so it can spin up again quickly in real time. If we have a look at some of the documentation provided by Canonical, you can see that it consists of the following types of daemons. We have monitors, which map the flow of the cluster. We have monitors that maintain the map of the cluster state, so effectively where is everything, manages things like the cluster configuration, and information about the data placement. We have the manager daemon itself, which maintains the cluster runtime metrics, dashboarding, and provides an interface to external monitoring systems. Then we have the OSD, that's the object storage devices. That's where the data is stored within the cluster, and that then is mapped using the manager and the monitor. Rados gateways use APIs to access this data. We also have metadata servers, which are used for storing metadata for the Ceph file system. And then we have the iSCSI gateway, provides iSCSI targets for traditional block storage workloads, so you can attach this as an iSCSI device for a virtual machine. Quick primer, Ceph stores data as objects within logical storage pools. A cluster can have multiple pools, each tuned to different performance or capacity use cases. In order to efficiently scale and handle rebalancing recovery, Ceph shards the pools into placement groups. Right, enough of the theory, and I've only just skimmed the surface, so please do go and read up on that documentation. I'm by no means an expert on this either, but hopefully if you follow this guide, you'll be able to replicate what I'm setting up, and you'll have a working cluster between 3 nodes that you can then use to comfortably house all of your virtual machines, safe in the knowledge that if a VM fails on a node, it should spin up on a new node with that existing data. So there are a few ways to set up Ceph. You can do it through the GUI within Proxmox, which is probably good for a basic setup, but it's not going to give us the options we need, or certainly I need in my MS-01 cluster, because I'm using the Thunderbolt network for that backhaul where I want that fast connectivity. So I'm going back to the Cyto GIS that we used in previous videos, and we're going to get this set up. In the previous video, I set up the Proxmox cluster, so all of my nodes are now joined and we can see those in a single dashboard. And to get Ceph up and running, we first need to install it. We then need to create some monitors, which I just showed on screen. Then we need to create some managers and then some OSDs. So let's have a quick look through the documentation and then we'll get into implementing this. So as you can see on the documentation, we want to install Ceph first. We want to initialize Ceph. And now this here is using the IPv4 network, which I mentioned in my previous video, doesn't seem to survive a reboot for whatever reason. I think there's a fix and I'll get onto that, but I'm just going to use the IPv6. It doesn't really matter which one you use as long as you're consistent. We then need to create a monitor address for each of the nodes. So we only execute this first one on node 1, and then we execute this on all of the nodes. Be mindful to change the IP address to correspond to that node. Once we've done that, we should be able to check then in the data center that all 3 of those monitors are up and running. Next, we need to add those managers. And to do that, we need to go to the Ceph tab, monitors, and then create 3 managers. So we can do that within the Proxmox GUI. Once we've got those in place, we can actually create the OSDs, that object storage device. So again, we can do that if the prior steps worked well within the Proxmox GUI. Hey folks, Jim here from the future. I've just cycled back in time with a quick edit for this video, which is going to tell you that you need to have a discrete storage device on each of your nodes for Ceph. That's right, you can't have what I had at the beginning of this video, i.e. that single drive that's probably got Proxmox and all your VMs running on a local LVM. You're going to need a separate device for Ceph. Ceph is going to have complete control of that device, and any data that's on there is going to be erased when you create it as a Ceph device. So you have been warned. Now onto a bit of a long story around the joys I've had and the delays in putting this video out, and some of the tweets that you've no doubt seen me sending out. So what happened? What were the complexities? Well, thankfully, please do watch the rest of the video. This is going to be really simple to follow if you aren't using specifically the MS-01 in the way that I was, and because of the way I'm doing my internet and OpenSense. So there's quite a few idiosyncrasies to how I have this set up that are probably not going to be applicable to you. But anyway, I'm going to tell the tale. So as I've mentioned in previous videos, I'm passing through the NICs to my OpenSense router on a virtual machine. Now that's for performance and also because I'm using a special SFP stick, but the long and short of that is it messed up the IO-MMU groups and the PCI lanes on my MS-01, such that when I put an NVMe drive into my MS-01, all of the lanes and groups changed. There's something really weird going on in there that I haven't actually quite gotten to the bottom of. I'm still missing one of my I226 Vs on that device. It just doesn't show up. I've reset the BIOS, all those sorts of things, and I've also stopped using pass-through because thanks to some awesome people online, I've managed to now have OpenSense using a virtual bridge instead of a NIC pass-through. That's been great because it means that now my NVMe card does show up on that device. One thing to also note is whenever you're doing any form of PCI pass-through, it's going to screw up your PCI lanes or at least change them. It's very likely that initially you're going to run the risk of being locked out of the device, because what will often happen is the addresses or the names of your Ethernet adapters, your networking cards, etc. will change as they get moved around. So if you've got something like traditionally VMBR0, which will be your web admin for Proxmox, that'll very likely change to something else, a different name, and you'll be soft locked out. Typically, you can just plug in an HDMI, a keyboard, etc. and change your interfaces and you're back up and running. That's a little bit more complicated, as I found out, because I'm passing through my iGPU. Now, because I pass through my iGPU to my K3S cluster, I don't get video out for Proxmox. So it was a bit of fun getting around this. Thankfully, because I've got that backhaul ring on that Thunderbolt, I could actually connect to one of my other machines and use that for a bit of problem solving. So that was really good. But if you don't have any of those, probably a good idea to stop doing the GPU pass-through so you can get some output onto a standard screen. Anyway, I hope that wasn't too complicated, and like I say, that was specific to how I have this set up. Now that I'm not doing the NIC pass-through, I'm hopeful I can fix that missing NIC, and also it means that for this video and the following videos, hopefully I can do some faux HA on OpenSense, because I'll be able to fail that OpenSense virtual machine over to other nodes in the event of a graceful shutdown for maintenance of a node, or just a failure of some kind. Anyway, I'm going to pedal back to the future now, and I'll hand you in the capable hands of old past Jim. What I'm actually planning to do for my Ceph is to actually install another NVMe drive into this machine to take off the weight of that primary drive and save some space, but also because it's kind of a waste to have a PCIe 4x4 running for my Ceph node when I know that the interconnectivity, i.e. that Thunderbolt ring network, only runs at 2.5 gigabytes per second, so using something like a PCIe Gen 3x4, which caps out at 3.5, that seems like a better choice. Plus, I've already got those drives, which are rescued from my previous Dell R730 sat idle, so I might as well make use of those. Once we set up the OSDs, we can create a pool from that. Again, we're going to be doing that from the GUI. We're going to be specifying then which VM disks we want to create. And then finally, once we've got all that in place, we can actually create some high availability. And we can do some settings for how we want high availability to be configured. And once we've done that, we should then be able to select VMs that are highly available, and thus when one of those fails, i.e. the node dies or the VM dies itself, it should seamlessly spin up onto another Proxmox node. Do note that if you're doing things like pass-through, that isn't going to be available to you. The downside of pass-through due to memory mapping on that node, i.e. you pass through a piece of hardware, it has a specific portion of memory, that cannot replicate over. So if we quickly remind ourselves of what my cluster looks like, I've got the 3 nodes over on the left, and currently Ceph is not installed or enabled. So let's resolve that issue right now. The first thing we need to do is go on to whatever you're going to call your server 1. I'm just going to do this kind of in alphabetical order, so I'll be choosing my Abaddon server first. So the first thing I'm going to do is to click on that node, and I'm going to hit the shell button. Now that we're in the shell, I need to go and install Ceph. So to do that, we do the PVE Ceph install repository from the no subscription. So going to hit return, and I'm going to say yes, I want to continue. That's gone away and installed Ceph successfully. So far so good. Now to get this up and running, I need to do the PVE Ceph initialize and then specify a network. Now, as I mentioned, the IPv4 isn't working on that Thunderbolt backhaul ring, so I'm going to be using IPv6. So I've specified here FC00::81. That's the IPv6 one for this Abaddon node, and I've just put in a /24. That's not the same as a /24 on an IPv4, so traditionally you'd get 254 usable IPs. In IPv6, I think it goes up to /64 because it's a much bigger, almost infinite address space. So the slash isn't really important here because, as I stated in the previous video, this is purely a private network that only these nodes have physical access into. So I'm just going to leave it as 24. It doesn't really matter for this one. So I'm going to hit return. That's now gone away and created that. So we're ready for the final piece on this node. So the final piece on this node is then to, once we've initialized the network, create the monitor and give it a monitor address. So this again is 81, and because 81 it sits within that network. So we should be able to hit return. That should go away now and create that monitor. Now, as you can see on there, I did actually get an error message. I'm not sure exactly why I got that error message, because if I head into this node here, and then I go to Ceph and then monitor, you can see I've actually got the monitor here. Now, it has got a status of unknown. I'll have to go and look at that quickly. It could just be because there aren't any other nodes in there. I'm going to spin up the nodes now by copying the same command onto the other 2, and then we'll see what happens. So going back to the instructions, I simply need to create that monitor create and then specify the IP addresses for the respective nodes on each one. So I'm going to go back to here. I'm going to click on each of these nodes. I'm going to fire up the shell and then copy those commands. So on the Sanguinius node, that's going to be 82. and on the Dawn node, that's going to be 83. So hopefully now those should show up. I'm getting the same unable to connect, but let's see if they created first. Okay, so after a bit of tinkering, it actually transpired that I needed to click on the monitor for Abaddon, and I needed to click restart. Now when that restarted, this actually then came up with population for the address and the version and the quorum. So hopefully now I can rerun the create monitors on Sanguinius and Dawn, and those will show up as well without that issue about complaining about connecting. And now that looks a little better. I did actually have to restart it again, and so does Sanguinius. So I'm hopeful. I do keep getting... there we go. Bingo. So I don't know why this is happening. It could be a nuance with my setup and IPv6. But if you get in doubt, what you need to do is restart the first one. So in my case, it's that Abaddon. And also you can actually hop into the settings by going onto one of your nodes. And I nanoed into the ceph.conf. And you can make some changes here. So for me, importantly, I had to have IPv6 set to true. And it's automatically populated these down here. Like I say, the key thing for me was to restart this node here, and you'll know if it's working because it should have an address in this part and a version. Now that we've got all the monitors created, we can now get started with creating the managers. So to create a manager, we click create. I'm going to create a manager on Abaddon first. That's done. I'm then going to create a manager on Dawn. Great news is you can do this all through the GUI. And I'm then going to create one on Sanguinius. And the good news is you can see that this is all up and running in the background. And now we have all three of those nodes up and running. Those managers are running. So now that we have the managers up and running, we're able now to move on to the next step, which is to define our OSDs, our object storage device. So as I mentioned earlier in my futuristic edit, you do need to make sure that each of your nodes has a discrete storage device that's only accessible for Ceph. If you don't, you're going to get an error when you try to do this. It will say there are no disks available. As I mentioned, I've added in some of my old NVMe drives, some of my redundant Dell R730, and now on each of these nodes I'm going to have to follow these steps. That is to click Create OSD. I'm on Abaddon here on the left, and you can see that that disk is here. Now I've got 1 terabyte disks in each of these, specifically set up for Ceph. Now I'm not going to encrypt these devices just because I'm going to keep this simple. But if you do want to encrypt it, make sure that you follow the documentation which is available on the website. Most notably, you're going to want to make sure that you have access to your keys should you require it. So once we've done that, we want to click Create. That's now going to go away in the background, provision that drive, and set it up for Ceph. Now, hopefully, if we refresh this OSD, we can now see that this one is up and running. And we need to now go ahead and do the same steps for the other 2 machines. So I'm going to click on Dawn, and then I'm going to click on OSD, and then I'm going to click Create OSD. This time it's going to have a slightly different address, but I'm going to click Create. That's now creating that one. Now that that's done, hopefully I can just click back off, click back on. And after a few seconds, this one has now populated here. So finally, we're going to do Sanguinius, create OSD, again, click create. It's going to work its magic, and then hopefully when it's done after a few seconds and just refreshing this page, we should see that one pop up. So now you can see that we've got all 3 available. And hopefully if we head back to the data center, and we go down and we click on Ceph, hooray, you can see that we've got all our monitors, our managers, and we're ready to go in terms of having 3 OSDs. Obviously if we scroll down we get some performance figures. We're not actually using it, so there shouldn't be any throughput. However, you can see the pooled storage here. So I've got about 2.73 terabytes, or tibibytes in this case, according to Proxmox. Now, as this is going to be replicated, I suspect that I'm only going to get basically a third, so you get the maximum available storage on a single device because it's triplicated. Now that we have this set up, we can actually click on any of our nodes, and let's go down to Ceph and click Pools. Now, we want to create a pool. This is basically like TrueNAS or Unraid or something like that, where you're setting a pool for that clustered storage. So I'm going to call this one VM disks, and it's going to do what it says on the tin. It's going to be on all of the drives, and it's going to have a minimum of 2, so it's going to always try and replicate up to 3. I'm going to leave everything else as default, and I'm going to leave the target size because I want this to be fully used by virtual machine disks only. If you're going to be setting up multiple pools, I recommend you read the documentation and make sure you allocate pools that are with the right size, i.e. you don't want to be over provisioning one at the cost of another. Make sure you plan out your pools ahead. I'm not sure exactly how you would change this and then add more disks and drives and increase the storage. That's something I'll probably get onto in the future. So if we click create, that's going to go away now and create that pool, and hopefully, yeah, you can see it in the background that that's now being created. Now, as you've noticed, the placement groups has changed in the background. Now, I don't want to get too deep into what placement groups are. I'll link the description to the documentation that you should go and read to more formally understand exactly what it is. But it's kind of what it says on the tin. The placement group is how that data is placed amongst the cluster, so things like the OSD, the monitors, etc., across, in my case, that 3 nodes. Now, in reality, Ceph is probably, well, it definitely is. It's meant to be built upon infrastructure that's far bigger than what I've got. So tens, hundreds of computers, thousands of storage devices, etc. And those placement groups can have a big impact on where that data resides, thus where it can be read from, and therefore the performance of the cluster itself and the applications that are accessing that storage. So for a home lab, you're probably going to be okay. And dare I say it, CephFS is probably a better solution overall, but there's nothing from stopping you running Ceph at home and learning how it works. Just bear in mind that this isn't going to be a true reflection of what it's like in the enterprise space. Anyway, we've now got this set up, so now we can get on to high availability and setting that for this pool. Now, I'm going to focus more in the next video on actual high availability, because as I've already discussed, I only have one instance of OpenSense running, and that's on this Dawn machine here. The benefit now is, as I mentioned earlier, I've got this running on virtual bridges as opposed to that pass-through. Now, true HA within OpenSense itself, as I've demonstrated on previous videos, that relies on basically having CARP between 2 WANs. I don't have 2 WANs, I've only got the one. So I'm going for sort of a faux HA using Ceph, whereby if this Dawn node were to collapse, go offline, whatever, I'm hoping that OpenSense will then fail over to Abaddon or Sanguinius, because the data for that virtual machine is triplicated on all of these nodes. And because I've got that backhaul ring where all of this is communicating and running, it should know that that node has gone down, and it should be able to connect and pull any data it needed between the 2 nodes. And ultimately, hopefully, and we'll be demonstrating this in a future video, OpenSense should come back up and I should get my normal network activity back again. I will have to make sure that things like the VMBR1 and 3 and 2, actually 2 and 3 in this case, those are replicated on these nodes so that it knows how to spin up. All the cables are in the right place already. I basically need to make sure that these 3 nodes are identical. So if we head into data center and then we go to options, there's a few things we need to change here to take advantage of our new setup. So one of the first things we need to do is go to the cluster resource scheduling and hit edit, and we want to rebalance on start. So this is going to use that CRS, cluster resource scheduling, to select the least loaded node when starting an HA service. That kind of makes sense from load balancing. You want to distribute the load and you want to spin this up on the one that has the most resources. So we're going to click OK on that, and you should see HA-rebalance-on-start- =1. Next, we want to go to the HA settings, and this is going to be really useful for whenever you're doing maintenance on your home lab. So let's click edit, and then we want the shutdown policy to be a migrate. So what this will do is when you shut down a node, say for example I want to do an update on Abaddon, it will migrate those virtual machines over to another node. Now that's going to be a little bit complex when you've got PCI pass-through. As I mentioned before, that won't work. But for anything that doesn't have pass-through, and you'll be able to go onto these respective VMs and enable HA, those will honor this policy setting. So setting that, we should get policy equals migrate. And then there's one final thing we need to do. That is to check the migration settings, which we already set here previously to use that Thunderbolt ring network. Now, one final thing that might be useful for you is to use this Ceph storage for things like your templates for VMs. So if you remember, things like this here is a template where I can clone to create cloud images, and also things like, on my instance, the local LVM, and actually no, it's on the local, the ISO images. So we can actually store ISO images and templates onto the Ceph cluster, so you're not having to copy them between or upload multiple times. To do that, you're going to click on one of your nodes, you're going to go to Ceph, and then you're going to click on CephFS. Because we haven't done anything previously, we're going to have to click create. Now we need to set a host for this. I'm going to keep this one as Abaddon. I'm going to click create. And then here you can see that that's now up and running. So I'm going to create one of these as well on each of the nodes. Now all three of those are created. Now we're basically going to create a bit like a pool. We're going to click create CephFS. Add as storage. I'm going to call this one ISO-template. So this will be ISOs and templates. Let's call it ISOs and templates to make it a bit clearer. Then I'm going to click create. That should now go away and work its magic and basically map all of these three into a pool so that we can add something to it and it's available on all of them. You can see on the left hand side, ISO's template has just populated. So with any luck, we also saw that one, yes, spinning up on Dawn, and yes, spinning up on Sanguinius, and those are all available now. So let me test this now with a file. Let's see what happens. Before we can use this though, we want to head up to the data center. We want to click on storage. Now within storage, you can see here the ISO templates at the top. So we want to click that and click edit. And here we should be able to tweak anything that we want on here. So we could even add snippets. We could get rid of the dump backup files if we wanted to. I'm going to get rid of the backups because I just want this for ISOs and containers. Then I'm going to click OK. So now it won't give me the option to save the VZ dump files, i.e. the backups, onto this Ceph cluster. I'll be using Proxmox backup server, which is on this node here, which is then saved to my actual true NAS, that's a physical separate NAS, elsewhere in my home lab. So now we're ready to go and test this out. So I'm going to click on Abaddon, I'm going to click on ISO's templates, and then I'm going to click upload. I've already got a file here for some ISOs, so let's choose something that's nice and lightweight. Here's OpenSense. So I'm going to click open on OpenSense, 1.85 gigs, going to click upload. That's now uploading to specifically Abaddon, but because it's being stored on Ceph with that CephFS, fingers crossed this is going to be available to use on all of the nodes. So I'm going to duplicate this here. And hopefully if I go to Ceph, you can see that I'm getting some writes going in now. Now I've got 600 megabytes of 2.73. It's writing. I'm not actually sure that this is probably the best way to monitor this. I will look at doing some better performance metrics in future, but you can see that that storage is going up. So that task is now completed. You can see it's kind of going over. Here's a peak of what, about 65 megabytes per second. Not massively impressive, I know, but we'll see what this is actually like in real terms performance. So now if we hop back over, we'll see that the Abaddon has OpenSense. Hopefully on Dawn, yep, we have OpenSense. And also down here on Sanguinius, yeah, we have OpenSense. So brilliant, everything looks as though it's working as expected. So hopefully now you've got Ceph up and running on your cluster, and you've got something that will survive graceful shutdowns and hopefully node failures as well. Plus you've got things like the CephFS, so that you've got clustered storage between your nodes. You can refer to the same ISOs, the same snapshots, all of those sorts of things, and obviously you can edit that to whatever you require. Really interested to see what sort of performance you've got on your cluster and how that compares to mine, specifically the MS-01 in this case, and some PCI 3x4 lanes. Really keen to see what that's like. I'll be doing more in the next video where we'll actually be testing that failover with spinning up some real virtual machines. I might be brave and I might even do OpenSense in real time recorded. Hopefully that's not a disaster. Anyway, thanks for watching everybody. As always, if you've liked the video, hit the thumbs up, hit that sub, and I'll see you on the next one. Take care everybody.